Today we will be starting 1-3 measuring segments. The first thing I want to point out is postulate 1.6 or 1-6, which is also the called segment addition postulate. What it says is if 3 points A, B, C are collinear, and B is between A and C, then AB plus BC equals AC. To illustrate this, we have a segment. There's A, there's B, there's C. If you take AB and add it to BC, you'll get the whole thing AC. Problem 1 is about measuring segment lengths. We have a line here, they have a bunch of points S, T, U, V on the line, and what they're asking in part A is what is the distance of UV? So how far is it from point U to point V? There's a book will explain it using absolute values and things like that. The easiest way I've found to do this is just simply to count. So we start at 10, we go to V, which is 14, so how far is it? That's 2 to the 12 and 2 to the 14, so that's a total of 4. So UV is 4. And the same thing with part B is what is ST? What's the length of ST, or how far is it from S to T? So again, we're going to count. This -4 to -2 is 2, 4, 6, 8, 10, 12. So the distance from S to T is 12. Problem 2 is about using the segment addition postulate. So we've already covered the segment addition postulate at the beginning here. And what it says is that if EG equals 59, what are the lengths of EF and FG? We have EF being 8x minus 14 and FG being 4x plus 1. So what I want to do here is I want to take EF and add it with FG to make EG. So we're going to have 8x minus 14 plus, and that would be EF, plus 4x plus 1 equals the total, which is 59. If we're going to solve here, the first thing we want to do is combine like terms. So 8x plus 4x is 12x. Negative 14 plus 1 is negative 13 equals 59. And then we're just solving. Add 13 to both sides. You end up with 12x equals 72. Divide by 12. And x equals 6. To finish the problem off, you want to go ahead and take the 6 and plug it back in for EF first, and then into FG to solve the problem. So if I do that, I end up with 8x, I end up with EF being 8 times 6 minus 14, which ends up giving me 34. And I end up with FG equaling 4 times 6 minus, or plus 1, I'm sorry. And I end up with 25. Problem 3 is about comparing segment lengths. So the question asks, are AC and BD congruent? So what we need to do is we need to find the length of both AC and the length of BD. And again, like we talked about in problem 1, just going to want to go ahead and count that. So let's talk about what AC is and the length of AC being. So we're going to start at -2 and we're going to go to 5. So this would be 2, 4, 6, and 1 is 7. So AC is 7. BD is starts at 3 and we're going to go to 10. That's 2, 4, 2, 4, 6, and then 1 to finish it off is also 7. So since they match, AC is congruent to BD. And you'll see that it's like an equal sign with a little squiggly line over top. I'll refer to congruent as that from now on instead of writing the whole word congruent. Problem 4 deals with using the midpoint. The midpoint, in this case is Q, is a point that is halfway between two other points, hence why it's called the midpoint. So Q is the midpoint of PR. What are the lengths of PQ, QR, and PR? With Q being the midpoint, what it's saying is the distance of PQ is equal to the distance of QR. So what I'm going to do is I'm going to take the value of PQ, which is 6x minus 7, and set it equal to the value of QR, which is 5x plus 1. So now I'm going to solve. So what I want to do is I want to combine like terms, which means I want to move the x to one side. I always move the smallest x. So 5x minus, that's going to give me 0x on the right, that's 1. 6x minus 5x is 1x, or just x, and the minus 7 stays there. Finish it off, add 7 to both sides, I end up with x equals 8. To find out what the lengths of each individual segment is, so I'm going to take the 8 and plug it in where x is, both in PQ and QR. So if I take 8 and plug it in, I'm going to end up with 6 times 8 minus 7, which is going to end up giving me this length of PQ, which is going to end up giving me 41. Now with this being the midpoint, I can definitely go ahead and replug 8 into here as well, but since Q is the midpoint, we're saying that the length of PQ is equal to the length of QR. So since PQ is 41, QR is also equal to 41. So that takes care of PQ and QR. To find the whole thing, PR, which is going to take PQ, which is 41, and add QR to it, which is also 41, which it gives me 82.